Okay, welcome to Schroeder Academy. Today we're going to start in Chapter 10. Today we're going to talk about different parts of circles, a lot of vocabulary today, and about the properties of tangents and how to use them in circles. This word tangent is different than the tangent that we learned about when we were talking about trigonometric ratios. All right, so our first page here will be just a little information that you can pick up on if you want to pause the video and write down some of this information, or just write as I'm talking. So we have a circle has a center, a circle has a diameter, and a circle has a chord now. A chord is a segment that goes from one side of a circle to the other side, and that's all it does, and it's just a segment. All right. A diameter is a special kind of chord that contains the center of the circle. So it is a chord. But a radius is not a chord, because a radius goes from the center of the circle to the outside edge. A chord must go from one side of the circle to the other part of the circle. It doesn't start at the center. All right. And so then we have two types of lines that intersect circles. We have the secant, which is a line that intersects a circle at two places. One here, one here. And then we also have the tangent. A tangent intersects a circle at only one place. So it just barely glides by and touches it at that one place, and that place is called the point of tangency. And so those are some of our key words that we need to know about when we're talking about circles. One of the big things about our lesson today will be is how do you determine if a segment is tangent to a circle? Not just by the picture, but mathematically. So we're going to get into that after we learn a few postulates and theorems and a little more vocabulary, and we'll talk about that. All right, and so then we have here coplanar circles. So if we have a whole bunch of circles, there are a bunch of different ways that circles can go. We could draw circles so that they intersect at 2 points. We can draw circles so that they intersect at only 1 point, where they're tangent circles. Remember, tangent is like 1 point of intersection. And we can draw circles in two different ways where they have no points of intersection. And those are different ways that we can have circles on a plane that intersect each other. Now, we said on plane because if we go three-dimensional, lots of rules can change. Okay, now these are common tangents, so make sure you write those common tangents down. There are two types of common tangents. This is called the common internal tangent. Okay, that's common internal tangent. So let's see if it'll recognize a common internal tangent. Yep, there we go, common internal tangent. And then we have the common external tangent. All right, so common internal, common external tangent. These are two types of tangents that we have. How do you know which is which? Well, if you connect the center of a circle from one another, if the tangent intersects that circle, then it's a common internal tangent. If the tangent does not intersect that circle, it is a common external tangent. So it's all about connecting the centers of the circle and whether that tangent goes through that or not. So make sure you know these two types of tangents. If you know that they're just called common tangents, that helps, but you might want to know the internal and external part also. All right, so our first theorem, theorem 10.1, says in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius of the circle. So if this radius and this line are perpendicular and it touches at one place, then we know that this line right here is a tangent. Okay, so if we look here, it says PT is a radius of circle P. So this is a radius. That means P is the center and T is a point on the circle. It asks, is ST tangent to circle P? So if it was a tangent, that would make this have to be a right angle. But we don't know that right now. So let's put that in the Pythagorean theorem and use the converse of Pythagorean theorem to check and see if that works. So 12 squared plus 35 squared equals 37 squared. And so if we do that work here, we do a little 12 squared, which is 144, a little 35 squared, which is 1,225, 37 squared, which is 1,369. We add those two together, 1,369 equals 1,369. And we could say, yes, it is tangent because it forms a right angle. And we know that because of the converse of the Pythagorean theorem that we learned back at the beginning of this semester. Okay, all right, so let's go to another one here. You can pause the video if you'd like and work this problem, and then I will pull the answer up so that you can see the answer. All right, taking a few minutes to work this. Let's check our answer, see how we did here. And so, yes, it is a tangent. The diameter of the circle is 20, and using the converse of Pythagorean theorem, we know that that's 10 and this is 10, so we can say, we're looking to see if that's a right angle, 20 squared plus 48 squared equals 52 squared. All right. Did you look and check and see if that's a Pythagorean triple? This can be divided by 2, which makes that 10. This is divided by 2, which makes that 24. This divided by 2 makes that 26. Oh, look, we can divide it by 2 again. And we get a 5, 12, 13 Pythagorean triple. It's good to know those Pythagorean triples. Remember, we're going to start checking those on the next few theorem quizzes. All right, formula quizzes that we have. All right, so let's do this one. We're going to work through this. Again, here it says B is the point of tangency, so that means that is a right angle. So if that's a right angle, we're going to go to Pythagorean theorem. So we have r squared plus 80 squared equals r plus 50 quantity squared. And so once I've plugged that into Pythagorean theorem, well, that's my hypotenuse, now I need to square this correctly. We spent a lot of time talking about how to square these kinds of things. This is 6,400. This is going to be r squared plus 100r plus 2,500. Remember that you have to write this, take this out of here and say r plus 50 times r plus 50 and FOIL it out. In other words, you're not going to get the correct answer. When I start solving this, if you want to pause the video and solve this and then check afterward, that'd be probably a good thing for you to make sure you know what you're doing. If I'm going to solve this, I'm going to subtract r squared from each side, so the r squareds go away. So don't think this was a quadratic, it wasn't. And so then I subtract 2,500, subtract 2,500, and so I get 100r equals 3,900 divided by 100, so r is equal to 39. And so then the radius of this circle is 39. And 39 feet would be even better because we have a unit of measure here. So 39 feet. All right. Okay, so here's one for you to do. So pause the video and do this one. All right, now that you've got this one done, check your answer. You should have had 10.5. All right, here is our next theorem. Our theorem 10.2 says tangent segments from a common external point are congruent. So what we're saying here is that if we have a point out here and we have two tangents, that means this piece and this piece have to be congruent. And actually they're congruent. If you remember back to first semester, if these are tangents, that's a right angle, that's a right angle. And so if I connect these, this will be reflexive property. These radius have to be the same. And so what we have is a little HL theorem going on here, which is what makes RS and TS congruent. It all has to do back with congruent triangles in our proofs. So now let's apply this. If I look at this problem here, B and D are tangents, and since they are tangents, that means that these two pieces must be congruent. And so we have 2x squared plus 5 equals 13. And if you want to pause this video and work through this problem, that'd be good for you. Then you can check and see if you know how to work it correctly. So as we're solving this, 2x squared minus 5 and minus 5. That gives me 8 divided by 2 for each side. X squared equals 4, and then I take square root. So x is equal to a positive and negative 2. Remember, we take square root of a number. You can have both a positive and a negative value, but in the case here, they actually both do work, and so we can keep it as both a positive and a negative 2. Now, if the negative value would have given us a negative distance, that would not have worked. So, pause the video, work this problem out, see how you do. I'll put the solution up here for you to check with in just a second. All right, so now that you've got this one done, you should be able to check your solution, see how you did. You should have had here that x is equal to 8. Remember, I could have asked you to tell me what's the length of RT, which you can plug it back in. Better be a 28. Here's another one to practice. So again, I want you to pause the video, practice doing this one, and then start the video back up when you're ready to check your answer. All right, so now that you're ready to check your answer, here is the answer. You should get 1. Remember that if you have a problem with some of these questions that you have to work, make sure you write down your questions when you're taking your notes so you can go over those when you get into class. All right, so last question. What is the perimeter of figure ABCD? Okay, it is a quadrilateral. And so if we go back and we look back to the theorem 10.2, it says that if a segment is tangent to a circle from an external point, then the pieces are congruent. So if I look here, this piece and this piece should be the same because they are from an external point A. So that means that's 5, this is 5. And so therefore we should have this one and this one here. So if that's 3, that one right there is 3. And if this is 6, this one's going to have to be 6. Well, if I take 6 away from 15, I get 9 left for here, which means gives me another 9 there. And so if I add up each side, looks like I have 10 plus 6 plus 12 plus 18. I end up with 46 is my perimeter of my figure. So you need to use this theorem to find the perimeter of the figures. You're just going to have to remember that theorem 10.2. Now, let's go back to the question that we asked at the beginning, remember, which was right there it is. How do you determine if a segment is tangent to a circle? So if we have a segment that is tangent to a circle, what do we know about that segment is the question I'm asking here. So I got the circle, I got this segment. How do I know that these two are, that this segment right here is tangent? And you should know the answer to that by theorem 10.1 is that if it is tangent, that the radius and that have to make a right angle. Okay, so complete pages 1 through 3 all. Make sure you show your work. There's going to be a lot of vocabulary there. Make sure you're showing all your Pythagorean theorem and all your work as you go. Have a good night.